So here I've drawn the spring mass damper system, where you can see that there's a force from the spring acting on the mass as well as a force from the damper and the external force all acting on the mass in the x direction. And if you write out Newton's second law of motion for this system, you get mx double dot plus bx dot plus kx equals the external force. Basically, the mass combined with the stiffness of the spring are what enables the vibration to occur, because while moving, the mass has inertia and wants to keep moving, but the spring will exert a force based on position of the mass to try to push it back to the neutral position at x equals 0. Together, these two components determine the natural frequency, which is root k over m. The damping force is proportional to the velocity of the mass, and it acts opposite the direction of the motion. So the damping force ends up producing the decay factor that you kind of see, and that the amplitude decays over time for the system. And the external force can do different things depending on how it's applied, but if you were to apply it in a sinusoidal mode kind of a thing, and you apply it at the natural frequency, then it can counteract the damping force and basically negate the decay.